In this video, we're going to be talking about a type of data that we can collect in the lab that helps us to identify a compound, or can potentially help us identify a compound if we don't know what something is. So today we're just going to be sort of understanding what this idea is, and then in the next video we'll talk a little bit more about how we actually use it. So what we're talking about is percent composition, and what percent composition is just the percent by mass of each element in a compound. So mathematically, the percentage of one element in a compound is just going to be the total mass of that element divided by the total mass of the compound, the molar mass, times 100. So we're just looking for what part of this whole thing is one particular element. So not really any different than figuring out the percentage of anything. Part divided by whole times 100 gets you the percent of that thing. So, for example, if we know the formula of something, we can just calculate the percent composition. So one way that this type of data can be used is to sort of match up. If you collect percent composition data in an experiment, you can kind of match it up to other compounds and see, well, this is what I found the percent composition to be. This is based on the formula, what the percent composition of these different compounds is, and see which one matches to help you identify what something might be. So being able to calculate the percent by mass of an element in a formula that is known is also a skill that you need to have sometimes. So we can determine the percent by mass of copper and bromine in CuBr2. So to do this, we're going to be using this relationship here. First thing that we're going to need a couple times is our molar mass of this compound. So that is going to be what goes in the denominator in our setup here. So our molar mass of CuBr2 is going to be the mass of copper, which is 63.546, plus 2 times the mass of bromine, which is 79.904. Since we have 2 bromine atoms, we need to multiply that by 2, and then that gets us a total of 223.354 grams per mole for our molar mass. So now to find the percent by mass of each of these elements, we're essentially going to be doing this calculation twice. We're going to do it once for copper, where we'll have the mass of copper divided by the molar mass of the compound, and then we'll do it a second time for bromine, the mass of bromine divided by the mass of the compound. So one thing we need to keep in mind is that it does have to be the whole mass of that element. So if we have multiple atoms of an element, we do need to take that into account. So the mass of copper in copper-2 bromide, there's only one copper atom, so it's just going to be the molar mass straight off the periodic table. There's one copper atom, so that is going to be 63.546 grams per mole. The mass of bromine in this compound, there are 2 bromine atoms. Each bromine atom has a mass of 79.904. So the total is 159.808 grams per mole for our two atoms together. So we want to make sure we're accounting for all of the copper and all of the bromine in this compound. So when we find our percentages, our percent copper is going to be the mass of copper in this compound divided by the mass of the compound as a whole. So the mass of the compound was this value up here. The mass of copper in our compound was right here, and then we'll need to multiply by 100 to put that into percent. So we'll have 63.546 divided by 223.354 times 100 gets us about 28.45% copper, by mass. To do percent bromine, we're going to do something really, really similar. So why don't you pause here, calculate the percent of bromine in this compound on your own. So same setup pretty much. We are going to have the mass of bromine in this compound on the top, the mass of the whole compound on the bottom. Oops. So that mass on the bottom is staying the same since we're talking about the same compound. But now our mass of bromine, we want to make sure that we are looking at the mass of two bromine atoms, since there are two bromine atoms in our formula. And then we will multiply by 100 to get us into percent. So we have 159.808 divided by 223.354 times 100 gets us 71.55% bromine, and this was percent copper. So in this case, since it was only two elements, you could also recognize that once you've calculated the percentage of copper, the rest of it is going to be bromine, and you have to add up to 100%. So you could also calculate it that way, and you should come up with the same answer. But being able to calculate, just one by itself is useful. Sometimes you're really only interested in the percentage of one element, like what is the percent of bromine in this thing. That might be the data that you have available to you to match up. So I did it out the long way, but that's kind of a shortcut that you can use sometimes when you're down to the last one. The rest of it must be that element, and it's all got to add up to 100. So either way works just fine. So in the next lesson, again, we're going to see kind of how this becomes more useful to us, that we can actually determine the formula of something from its percent composition data. But for now, this is just how you determine it from the formula and sort of what percent composition is representing, is what fraction or what percentage of the whole compound is one particular element.